4.7 optimization. Optimization means ultimately to maximize or minimize some function. So now that we have the techniques of applying the derivatives to find where functions have extrema, that is, to use the first derivative test for the most part, we can apply it to a wide variety of situations now, not just the graphing that was done before, but to more practical problems. For example, I'm going to use this example to demonstrate the idea behind optimization and simultaneously a method for these types of problems. So let's say you have a box. Okay? You have a rectangular solid, a rectangular box with square base. Okay. And we're going to use let's say centimeters squared of material a rectangular box with a square base. We'll use 600 centimeters squared of material to construct it. Okay. And we want to know how to construct it. What are the dimensions of the box? I.e. length, width, and height. What should they be? So that it will contain the most volume. Cause the box to have maximal volume. All right. I hope the question is somewhat clear. That you have a box, maybe something like this. Okay. There's approximately a square base. Okay. So if it's a square base, and that means both of the length and the width would be the same value. So I don't need to introduce an x and a y here, right? Two x's will be sufficient because they are the same value throughout, because the box is square on the bottom, you might say. And then you have some height here, which is not necessarily the same as these. And so there's y for the height. Okay, so you have length, width, and height. And we're covering the box, or we're constructing the box with material of the amount 600 centimeters squared. Okay, so the surface area, I'm just going to use S for surface area. The surface area is 600 centimeters squared. The volume is unknown. Okay? Want to maximize it. As you change the dimensions of the box, you can change them in such a way that you will always maintain 600 centimeters squared covering it, in a sense, or constructing it. Simultaneously, the volume would change depending on the values you would select. So, in other words, you could create a box with a very narrow base. You can make the length and width very small, and you could stand it very high. You would increase the value of y, and that would maintain this particular surface area. Or you could widen the base and have a very broad-based box. The two x values could be very large, and y would have to shrink accordingly to maintain the surface area of 600. And one of these types of constructions will maximize the volume.